Hey, what's going on, everybody? It's your boy Algebra coming at you live from my living room. I'm gonna go ahead and teach you about the rational root theorem real quick. The big idea behind this is that yesterday we started talking about synthetic division, but I gave you all the dividends, I gave you all the divisors, I gave you everything, and just had you work through a process. Eventually, I'm going to start giving you a polynomial like this bad boy, and asking you to just solve it, to just go and graph it, and not giving you any of that extra guidance. And so if I'm going to be able to do that, I need to make sure that you know how to get the process started on your own. And that's why we're going to talk about the rational root theorem today. So while you're copying this down, I want you to understand a couple things are going to be taking place. The first thing, yes, we're about to talk about the rational root theorem, but we're also going to have an opportunity to review the synthetic division process from yesterday. And then we're also going to be able to talk about a couple of things that you may have noticed, but you probably didn't, as far as the results and where they take you next in the process. So hopefully you've got this all copied out now, and then we're ready to go and do a synthetic division problem. Process that we outlined yesterday said, start by listing out all the coefficients in order from the highest power down to the lowest. 1, 5, -5, -45, -36. Solve the dividend, the divisor. Solve this bad boy over here so that you can figure out what number you're going to use in the synthetic division process. Send down the 1. When you're coming back up into the actual synthetic division house, you're going to be multiplying it times that number that you boxed up. So this becomes -4. Add down. Multiply by that -4 and then add down. Same thing again. Times -4, then add down. And finally, we get to this point where we have 36, and it becomes 0 for the remainder. What that tells me is that if I had gone in the very beginning of this process and went to go find f of -4, it would be 0. The remainder is actually going to tell you what is the function value at that point. So whenever we get 0, that's actually a really good thing. That tells you that it's one of the x-intercepts. If you get a number like 243, that would mean that this would have been -4, 243. Depending upon which numbers I give you in the process, you're going to end up in a different place on the graph. So the question now becomes, 1, are you done with the synthetic division? And then secondly, if you're supposedly going to be figuring out function values, how do I know what numbers to plug in? First answer, no, you're not done. What if you decided to keep going? What if I said, now that you have this answer, I want you to divide it by -1. Could I just start from right here and keep going? Absolutely. What I've done so far is I figured out one point on the graph. It's not taking away from the rest of them. So I could just keep on going from where I left off. Go down 1. Make it -1. 0. Make it 0. -9 turns into +9. And now I have another remainder. So what this tells me this time is that f of -1, same function, is also 0. But now it looks like I have 3 terms left. And if I have 3 terms, I want you to remember what we did on the very first problem. So we said this is really x squared minus 9. That's factorable. I could have made this x plus 3 and x minus 3. And if it's x plus 3 and x minus 3, that means that x could be -3 or x could be +3, which is telling me 2 more zeros. So what all of this means together is that I have a graph with a leading coefficient that's positive. It's an even power. I have x-intercepts at -4, -3, 0, and +3. And every time it has a multiplicity that is 1. Here's to the graph. So everything builds together to create this one simple picture. So let's do it again. New question. Says find the zeros by synthetic division. And that's all I'm giving you. I'm not telling you what to divide it by. I'm not telling you what to put inside the box. You have to be able to figure that out for yourself. And so looking at a problem that we can factor is going to actually give us an opportunity to go through a process, knowing what the answer is supposed to be so we can kind of verify that the process is actually working for a purpose. The idea is this. I only want you to use the following numbers: ±1, ±2, and ±1/2. That's not for all problems. That is for this problem only. And the reason why I'm choosing those numbers is because of the leading coefficient and the constant term. If I take the constant term and put it over the leading coefficient, I would have 2 over 2. That's 1. But that's not the only possibility. What I'm actually looking for in this P and Q situation is I am using the factors of P over the factors of Q. So that list of ±1, ±2, and ±1/2 is actually the same idea as what I've written here. The possibilities for factors of P were 1 and 2, positive or negative. The factors of that other part of the fraction, it could have been +1 or +2. So these are the only things that it makes sense for me to try in the synthetic division process. It could be 1 over 1. It could be 2 over 1. It could be 1 over 2. It could be 2 over 2. But when I simplify those down, it's actually only those choices that I listed out before. This is called the rational root theorem. It basically says the only numbers worth choosing come from this relationship. I'm not going to give you any guidance. You have to be able to recognize the only numbers that you should even consider in the synthetic division process have to come from that P over Q relationship. That is the constant on top and the leading coefficient on the bottom. This is a huge deal. So in that process, I don't know which one of these is going to work yet, but I do know, I absolutely know that these are the only rational numbers that could possibly work. So let's just choose one. It doesn't matter which one you start with. It's your choice. I've got a feeling that x plus 1 would be a good factor in this one. So I'm going to try to use -1. -1, 2, 5, and 2. Bring the first one down. Send the next one up. Bring it down. Send the next one up. That's not 0. It didn't work. Oops. I said it was going to. I lied. Whoop me then. Let's try something different. How about -2? 2, 5, 2. So I try it. 2. That would be -4. 1. This would be -2. That one did work. And our remainder says that this, we now know that this is one of the zeros of the function. We also know that after we take that one out, what we're going to be left with, it'll be this guy, 2x plus 1, which says that our final answer, the other option, will be -1/2. That was a possibility. The -2 was a possibility. So both of our answers actually did show up in there. The fully factored form of this would say x plus 2 times 2x plus 1. It is the same equation as that polynomial that we had before. We're going to try this again. So as I look at this next problem, I'm confronted with a little bit more challenging situation. And that's because the list of factors for 2 and 6 are much longer than the list of factors for 2 and 2. There's a lot more possibilities that I need to consider. The process is not going to change though. I'm looking here for the numerator and I'm looking there for the denominator. I have the possibilities of using a +1 or a -1, a +2 or a -2 on the top. But on the bottom this time, I could use a +1, I could use a +2, I could use a +3, I could use a +6, or I could use their negative versions. So this time I actually have a lot more options to consider. But that's a whole lot better than looking at the infinitely many possibilities that exist in the real number system. Do I have a preference on what you start with? Yes. Knowing me as the person who's giving you these problems, I would start with numbers like +1 and +2, -1 and -2, 1/2 and -1/2, +1/3 and -1/3. I'm going to try to use small numbers to kind of simplify the process a little bit. But I can still use whatever I want. This time I'm going to start off by choosing, I don't know, let's use a 1. Let's see what happens. And if it doesn't work out, that just tells us that it's not one of the zeros. It's not the end of the world. We'll just try something different if it doesn't work. Here you go. Straight down. Multiply to get back in. Add down. Multiply to get back in. Add down. Multiply to get back in. Oh man, Miss Somerville, you a genius, man. That worked every time. I know, I made up the problem. So here we go. What do you do now? How do we know that none of the rest of them work? Well, again, you got to remember what this says. This says that you have a trinomial that looks like this, which happens to be factorable. And because it's factorable, we know that our answers are going to be x minus 2 and 6x plus 1, which gives us final answers of x is 2 and x equals -1/6. Having these answers is well and good, but the biggest thing that you guys need to understand right now is that practice is what's going to make you have more consistent progress. The test last week wasn't the greatest in the world, but you guys can earn some points back for that right now. Rest of the period you can either work on your homework, which is listed at the bottom right of the page, or you can work on test remediation. This is a way for you to earn back some of the points that you may have missed on your test, which you will receive back on Monday.